So with MRI or magnetic resonance imaging, it's possible to produce a map of hydrogen density, so areas with lots of hydrogen ions and areas with less hydrogen ions. Those areas with higher density of hydrogen nuclei produce a signal associated with their relaxation, or the time it takes for the hydrogens to flip over when a radio wave is sent in, and then flip back and release that radio wave. That time difference, T1 and T2, these time differences are used to contrast, or to each particular tissue of the body has different values for T1 and T2. Those will be looked at in a little bit later in another video, but that difference in T1 and T2 values, so some are more weighted towards some tissues are weighted more towards the T2 value, some are weighted more towards the T1 value. Now, some nuclei, that's the first time, T1. Some nuclei will relax or return to their original position at a T2 time much later. And we'll look at the different types of tissues that make that happen. But you can, depending on the T1 and T2 times, you can distinguish between those various tissues. You can also change the image to look for more towards the T2 type instead of the T1 type. Quickly, T1, T2 are relaxation times. The time taken for the nuclei to flip once a radio signal is sent in, and then return to their original precession, and the radio signal is sent back out. The time between going in and coming out is the T value. Some T times are longer than others, we call them T2. The initial return of that radio wave might be T1, a shorter time. Different tissues have different T1 and T2 times, depending a lot on the amount of free water available within them.